Welcome to Johnny Does It All. We are here today. I'm going to be talking about a little bit of electronic work. On this channel, we do a little bit of everything. We're not limited to anything. A lot of channels out there on YouTube do specific things. I had this grand idea of whatever I happen to be doing in my life at the time. I'm going to document it, and maybe it'll help some of you people out there. I'm into film work. I'm into making music. I'm into the great outdoors, fishing, hiking, survival, all these things. Cooking, vegan cooking at the moment actually is a big thing. I do vegan cooking, keto vegan actually, to be specific. Today, specifically, we are here to talk about fixing a USB 2.0 port, specifically on this Focusrite Scarlett 2i2. And as you can see, it's got two XLR ports that double up. That side. Two XLR ports that double up, also has 1/4 inch. It's mounted with phantom power. On the back, it has a USB 2.0 port. And right now, we got a very loose connection. As you can see, if I plug it in, which I'm going to grab my cord, come back here, grab this guy. If I were to plug it in, it is very loose. So if I wiggle the cord, you'll see that it comes on, but doesn't stay on for very long. And that's because we got a lot of wobble and a lot of playback here in this USB Type B connector, which is very common for a lot of musical instruments like MIDI controllers, even printers, have this USB Type B connector. I wanted to show you what that looks like. So it's this cord right here, right? So, and the replacement, which by the way, I put in this nifty Ziploc bag. Am I allowed to say Ziploc, or am I dropping names here? Anyway, they look like this. So they're these like little tiny, USB connectors that can be soldered in. This specifically for the Scarlett, they make two types of these connectors. There are 4-pin and there are 5-pin. This specifically, because I've done some research ahead of time, I know once I open this chassis up, that there is a 4-pin connector inside of there. And just to let you guys know, the price that I'm about to show you on these connectors may not be current from when you're watching this video, but right now you get a pack of 10 of these 4-pin standard Type B female socket connectors, USB 2.0, 10 of them for $569, and it's free shipping when you have Amazon Prime. Okay, and I may or may not drop some affiliate links in the description below. I'm new to this. I've done other YouTube channels before, but this is kind of going to be a new one of its kind. And yeah, again, we're going to go into a little bit of everything. For this project, like I said, you're going to need your new USB 2.0 port, obviously, because that's what we're replacing to fix this problem of a loose connection. And I also want to go over some things that you might need, okay? And then I'll also go over some things that you'll definitely need. So you might need, and I always have this on hand because I do a lot of electronic repair. This is CRC's QD electronic cleaner. It's quick evaporating. It's awesome. It cleans all of your electrical connections, gets rid of all that gunk and gook. Is that even a word? I think it is. I think you can look it up in Webster's, right? Anyway, but yeah, this is good stuff. I recommend any type of electronic repair you're doing. It does not leave any residue behind. Try to use it in a well-ventilated area. It does kind of smell kind of funky, as any usually industrial strength cleaners do. Other things that you might need is a pick. I will probably most likely be using this pick to apply what's called rosin or flux to my circuit board when I'm repairing that. You may not need it. Some people like to use brushes, but I know this is going to be a very precision intense job, meaning those pins are very close together, and I want to make sure when my solder is flowing, it flows and does not bridge connections together that are not meant to be bridged. And you'll see what I'm talking about once we get to that place on the board. So again, pick might be a good idea. This is the crazy tool. Everybody's got one of these, a butter knife. So inside of this chassis, there's going to be 2 pins that basically, hold the circuit board into the chassis. And those two pins, those tabs, or some people would call them ears, need to kind of be flexed open to basically drop the circuit board out of that chassis. By the way, I realized before this point, I've been kind of looking at my monitor above my camera and not looking directly into the lens. That is bad video making. Help me out, YouTube. Anyway, so again, some of the might things you might need. This right here, tabletop vise. So this tabletop vise is basically to hold our circuit board into place. And it's not necessary. You may have some other tool you like to use, but I'm basically going to be clamping the circuit board very carefully because circuit boards are very delicate. Careful, people. Don't clamp it down. Don't be Hercules, right? So anyway, you might want to use that. I'm going to put this down for now. So those are the mites, right? Again, you can kind of replace this maybe if you have a long enough flat-bladed screwdriver, right? You could probably use that. Okay, the things you're going to definitely need, okay? First off, solder, okay? This is just standard electronic solder. It's not plumbing solder, okay? It's fine solder wire. Specifically, the one I'm using today is a 6040, or what's known as a 6040, and this is 50 grams. As well, this is rosin paste, or flux. This is what's used to basically help develop clean connections when you're doing solder. And you know, some people swear that the flux inside of their solder, because a lot of solders comes with flux inside of their wire, is enough. I would disagree. For me personally, in this specific job, sometimes it is enough, but when you're doing very precise connections and you're sitting in there trying to make sure that solder flows exactly where you want it, it's not a bad idea to just apply some of this with that pick and just make sure that that solder goes in and just goes right exactly to that place that you want. It's beautiful. It's awesome, right? Who really gets excited about electronics like this guy? I swear, nobody. But anyway, and then another thing you could also get, okay? By the way, all this stuff came from Amazon. I bought this specifically so that I can kind of show you guys and make this video. This is what's called, I'm gonna open this up, by the way. This is known as desolder wick. Okay, and again, I'll probably drop some of these affiliate links below. Remember, if you were to click on my links, you don't get charged extra, but it does go help this page out. They're just, you guys know what affiliate links are. You see them everywhere every day. But anyway, this is what's known as desolder wick. And this one's called No Clean Wick. And what this does is you apply a little bit of that rosin on here. You pre-tin your wire with some solder on your, you pre-tin your soldering iron with a little bit of solder. And once you touch this connection, the solder connection on your circuit board to this solder wick, this is like a sponge. It will basically soak up any of the old rosin that you're trying to get rid of, or any of the old solder as well. It'll suck right into this desolder wick, and you'll have basically a nice clean board just waiting for that beautiful new solder to come in and clean your connection. So clean your connection and you will have clean connections later. Does that even make sense? Probably not. Anyway, let's get more into it. So to take this chassis apart, again, I said you will need a screwdriver, and I also said you would need a knife to take those tabby ear things off. And also I would say you need either a pair of pliers or a wrench, and that is because on the back of this Scarlett, I will show you why all these things are necessary. Okay, you flip this over, you have these two 1/4-inch ports here that are held in to the circuit board, these nuts. Okay, also on this, you also have 3 Phillips head screwdrivers, but they are recessed into the chassis. And so you have one right there, you have one on this side, right at the very, very top, and then you also have one in the middle. This middle one is longer than the other 2 corner screws. Make sure you keep them separate, and when you put this all back together, you put the 2 shorter screws at the top and the longer screw in the middle. The 2 smaller screws at the top are mounted to aluminum, which is what this chassis is mounted to. And on the inside, you will see, I've looked at the schematic, on the outside, you will see once you open this up, that the middle screw was attached to plastic, which is on the circuit board itself. And once you get this back plate off, this front plate will slide out. Once you've opened up those two ears that are on the very top of this chassis, you'll go in there precisely with that special tool, that butter knife. You'll pop those kind of open, kind of flex them open on both sides, and you'll push through from the back to the front, and this front piece will slide out and come right out, okay? You'll basically just have the metal chassis kind of hanging around. You'll have the back plate, and then you'll have the main board, which will be attached to all of this on the front fascia of this audio interface. And that board is where you'll perform your electrical surgery, take off your old USB 2.0 port and replace it with your new fresh USB 2.0 port. And I want to show you the difference before we get into it of what it is supposed to sound like when you have a nice clean USB 2.0 port with no flex. This is going to be the new one. Take our USB 2.0 port, click it in, and you hear that nice beautiful click. There is no wiggle, there is no nothing, and even to get it out, it even is hard to get off. So, did I say that? I really did. Anyway, getting into it. We are going to get into this chassis. Let's go in for a closer look and let's get this thing started. Again, thank you for watching. Stay tuned. We're going to get into this thing right now. Okay, so here we are with our Focusrite Scarlett, and this is the 2i2 version with USB 2.0 on the back. And we're going to do the very first step, which is removing the circuit board, which contains that USB 2.0 connector on it. But to get into that, we got to take this guy apart, right? So we're not going to do anything on the front at all right now. What we're going to do is we're actually going to turn this over to the back, okay? And like I was telling you earlier, we have 3 screws. We have one here, we have one there, and we have one here. So what we're going to do is take this precision screwdriver, okay, and we're just going to simply start loosening our screws. Okay, it's about as loose as can be. Go for this corner here. And then also our middle one. That's 3 screws total, if you were keeping count. Remember, this middle one is the longer one I was telling you about in the intro. We'll just put that off to the side. And it's always a good idea when working on electronics, especially bigger circuit boards, to keep everything organized. Always remember, different lengths of screws and things like that. It just helps putting everything back together the way it was, that much simpler and easier. Okay, so whenever you have screws that, kind of are screwed into metal, which these two are, sometimes they're so recessed that even when you've fully screwed them in, they don't want to just come off on the screwdriver. So what I do is I just turn it over and they fall out. So we're going to take both these screws and push them off to the side. Okay, we've removed these 3 screws. Next thing to do is to actually remove these 2 nuts off of our 1/4-inch ports or 1/4-inch jacks. We're going to use this set of pliers to do so. Kind of pre-loosen those. Start unthreading these. Come off just as simple as that. Second one. Boom. There's the second nut. And now we can just pop that right off. Put our plate next to our other parts of disassembly to the side. And we have our circuit board exposed. As I was telling you earlier, you had those 2 screws that were mounted into this aluminum chassis, and you also had that longer screw that was mounted here on this plastic part of the circuit board. Okay, this will not slide out through the front if we do not loosen the 2 ears, one that is here and one is here. You cannot see what I'm talking about unless we actually look in to this chassis and see exactly what I'm talking about. And for that purpose, I'm going to actually change shots here and try to see if I can focus inside of this chassis so that you can actually see exactly what I'm talking about. So let's do that now. Okay, using my phone as a flashlight because I realized my other flashlight was way too bright. I kind of positioned myself here with the camera to hold my flashlight in place while holding this chassis so that I can show you these tab ears that kind of hold this circuit board into this chassis. If I were to go down here with this knife, this right here is that tab. Boom. And I've kind of pinned it, this knife, this flat knife, in there to kind of show you what I'm talking about. And there's one on both sides. There's one here, which I have, and there's one here on this side, okay? So what I'm going to do is once I've kind of stuck my flat instrument into there, I'm trying to do this while looking at the camera at the same time. It's not always the easiest thing. I'm sure you guys can realize that. So what I will do is kind of slide in from the side, get right in there. Okay, and I'm going to just kind of, once I've wedged myself between the ear and the chassis, I'm going to just turn my knife either to the left or to the right and just kind of disengage it. And at the same time, I'm going to remove this phone out of the way now that you kind of know what I'm talking about. And what I'm going to do is, as I turn very gently to kind of disengage that ear from the chassis, is I'm going to push on this circuit board outward towards the front of the chassis so that it basically just loosens up. Okay, now it's important, we got to do this on both sides. And don't get frustrated if they kind of clip back into place. That kind of happens. A lot of things are kind of set up this way, but I've kind of run into situations with other electronics I've repaired in the past where, you know, you unclip one side and you go to the other one, and once you've unclipped that one, the other side clips back into place. I've seen that happen quite a few times. I've experienced it. Don't get frustrated, you know, just keep your eye on the prize, and we're going to get through this thing. So let's do that. And there we go. That one's popped. Let's go to the other side. I don't know if you guys heard that click. Remember, I'm keeping constant pressure with this thumb on the back of the board. Just nice, even, gentle pressure as I'm clicking this. And I'm just popping that ear down and click. So I just felt it kind of give way. I don't know if you saw it slide. I wasn't looking at the monitor, but now this will just slide right out. And these were the ears that we were talking about, right? So on the inside of this chassis, it attaches to these ears. It's like a little push button. And in order to get them off, you kind of just needed to move these away so that it would slide out through the front. So now that we've removed this board from our chassis, and we now just have, you know, just a plain piece of aluminum, we now have our circuit board exposed. And guess what we see here? We have our USB 2.0 port, 4-pin connector. And to confirm, let's look at this here. We have 6 connections, right? But the reason it's called 4 pins is because on the back side we have, 1, 2, 3, 4 pins soldered in. And then we have the ears, which makes 6 total soldered connections. If you were to look close up on this board, I want to show you. Let me see if I can zoom in here and focus. Oh yeah, I can. There we go. Beautiful. So we have 4 connections here. Those are our main electrical connections. And if you notice, they're not bridged, meaning none of these soldered points are touching. And that is important, as I was stating before, to have a good cleanup job when you're removing the old one, and then when you're applying that rosin, that flux, that solder flux, to make sure that every time you're making a new connection to this solder point, you're not going to bridge these connections together. They're not intended to be connected electrically. So let's get into the next step. We're going to start preparing. We're going to get our soldering iron nice and hot. We're going to prepare our whole area here and just get ready for the next few steps to get this old port off. All right, guys, here we are. We've 90'd our tabletop vise. so that we can bring the work to us and keep it nice and convenient at a nice 90-degree angle. It's flat right in front of us. And as you can see, we have our connections right in front of us ready to be worked on. One of the things I haven't mentioned in the video so far is a desolder pump, what some might call it. It's a common tool that we use in electronics, and what it does is it's spring activated. It's got a spring on it, and when you push down on it, it kind of loads it up. And when you push this button, it pops the plunger out, right? That springed plunger. And this is the tip, and it's basically a solder vac. They call it a solder vac. And what it's used for is once you've heated up these connections, you can basically, with the solder still hot, you can come right in there sometimes without even having to use that desolder wick and just hit that plunger and it'll pop the solder up into the vac, and you can basically plunge it back out and throw it away. That's a common way that some of us use to get rid of old solder. And it works pretty well, but sometimes you do have to go in there with your pre-rosined desolder wick and clean up some of these connections. And this is, like I said earlier, this is like a sponge. It'll kind of just soak up some of that old remaining residual solder. So yeah, I just wanted to get into that, and let's see how our soldering iron is doing, if it's hot enough. And we'll know by pre-tinning our solder. There it is. If you see smoke, that's usually a good sign. And in fact, this solder is melting. This brand new solder is melting. So we kind of know what's going on. Here's what I'm going to do. I'm going to hit this plunger on this solder vac. Just in case this does work, let's give it a shot. I'm going to go for that first connection. See if it gets hot enough. I actually did pretty decent, good job. Sometimes what I like to do is actually just go straight up and down onto it. Heat her up and kind of... Oh, I didn't pre-plunge it. Is that even a word? I'm going to use a lot of those. Is that even a word? So yeah, I think what we'll do is we'll use the solder vac, and we'll basically, in combination with the desoldering wick, we'll go in there and do some final cleanup with that. Yep, it's actually pulling some of that out, which is great. If I can get the majority of the solder out with this method, I'll do so. Yep, nice and clean. Going for that fourth one. I don't know how well you guys can see this. I'm sure it's not the greatest in the world. I am using one of my 4K cameras, but I know there's only so much you can do when you're on these microscopic boards. But yeah, basically what it's doing is it's removing the majority of the solder, which is great. And now you have these two ears that kind of hold this port into place. Let's kind of melt some of that solder and see what we can get here. And I'm being ever so gentle with this because I know there's a lot of other connections around it. So just keep that in mind. What we might need to do is tin our wire again, heat up some solder on her, and yep, that'll usually help you kind of break them, you know, get these connections loosened up. So I'll kind of melt her down, get her nice and hot, get her right there. There we go, beautiful. Yep, it's pulling a little bits at a time. That's okay. This isn't piecework. Remember that? My mother used to always say that. This isn't piecework. My mother worked in a factory for many, many years. Same did my father. And one of the things they'd always say, this isn't piecework. Because, you know, if you rush these things in life, you know, it just never comes out right. Slow and steady wins the race, guys. So take your time with it, and you'll get it right. You know, part of me wants to cut these videos a little bit short because I know some of you guys might get bored And I know our attention spans aren't what they were years ago because we're so used to fast content. But when it comes to things like this in life, you do need to have time, and some people need to learn step-by-step procedures and learn things, and this is why I'm doing this, you know. But there's also going to be other videos on this channel, you know, doing other things in life, not just electronics, you know. Like I told you earlier in the video, we do hiking, we do cooking, and ooh, that was a beautiful solder vac right there. That cleared that port right out. I love that. Electronics has always been something I've been interested in my whole life. You know, when I was a little kid, I think even before I hit the age of 10, I was already like taking things apart in the house and learning how to put them all back together again. When I was in high school, I took some courses, you know, learning, you know, circuits and all these things, you know, resistance bands, capacitors, their purposes, how to read them apart, you know, soldering boards together, learning the difference between series and parallel, what a series parallel circuit is, all these things. And you know, it's funny, I didn't know how much I would end up using it in life. And even though, you know, I don't really do electronics for a living, it's helped me be able to repair things in my life, and I don't have to go out and have somebody else do it because I have a working knowledge just enough to get things done. You know, same thing with my car. Don't be afraid to work on your cars, guys. If you're ready to learn, there's so many videos out there of people doing this stuff, and you can do it. You know, these dealerships don't want you to do that. Of course not. You know, they want you to spend money. But you know, maybe that's some other videos I'll do too. Maybe I'll work on some cars and show you guys some things that I can do. You know, I've taken whole engines apart and repaired transmissions, and there's a bunch of things. I've repaired musical instruments. There's an old saying, I don't know if you guys have ever heard it, I'm sure you have, you know, and I believe it goes something like this: give a man a fish and you fed him for a day, teach him how to fish and you fed him for a lifetime. So take that to the bank. So this is pretty much ready to be popped out of place, I believe. I'm going to start feeling this connection, kind of see if this connection is warm to the touch, which it is, but it's not extremely hot. And what I want to do now is see if I heat these up, slowly keep like downward pressure on this port, it'll kind of just pop through, and it should slide right out. So we're kind of cleaning as we're pushing. The other thing we kind of want to do is see these little ears. One way that it's going to help us, we got to kind of pry these ears inward towards the port from the outside of the board inward, so that those clear the hole that's holding this port into place. One of the things I'm going to do is I'm going to stick my soldering iron directly into my rosin. Okay, and what this will allow me to do is actually melt the rosin a little bit and stick it on, you know, stick my desoldering wick into the rosin, and it'll absorb like a sponge. Okay, and what this will do is once I've tinned my soldering iron, okay, what'll happen, this is what I was talking, why it's important to kind of use this desoldering wick, is I can come in here now, and with that desoldering wick pre-moistened, it'll kind of just suck up everything around there, you know, really clean up and do a really good job of, you can actually see that happening on camera. It's actually like turning from a brownish color, like that copper color, into a nice silver solder color. And that's because it's sucking and soaking up all of that solder. So we're going to do that again. Okay, we're going to come back onto the board, do this to this other side here. Okay, don't be afraid of this stuff, guys. Just let it soak it right up. Beautiful. I know this video probably doesn't do it all justice, but on my side, I mean, this is just amazing what's happening. You know, it's kind of visually pleasing. It's, you know, aesthetic to the eye as you see it happening. I think what we'll also do now is we'll work on these 4 connections. Let that soak up. Now, if you ever feel this desoldering wick is getting too hot, just kind of move your fingers backward a little bit on the wire, and we can kind of not feel the intense heat that's happening at the forefront of things. Okay, so that's the 3rd hole. Let's go to the 4th one now. I think once we've reached this point, what we'll do is we'll get a pair of needle nose pliers and see if we can bend these ears inward towards the port to kind of see if this thing drops out. Might take a little bit of wiggle, a little bit of effort to get it out, but that's okay. We got time, right? So let me go get those needle nose. Here they are. I think they need to be oiled a little bit because they're not flexing the way I would like them to. And we're just gonna kind of take those ears, bend them inward a little bit. Might even be able to use like a screwdriver or something and pop those inward as well. So let's get right in there. Kind of bend them outward actually is what I'm gonna do. And I think what we'll also do in this situation is we'll take our soldering iron back to the board. This should be the final push here. What we're doing is we're trying to heat up all these elements, all 4 of them. Kind of keep going simultaneously back and forth so they stay nice and hot as much as possible. And we're keeping constant downward pressure on that port. And once this drops out, just kind of keep going at it. Once it drops out, we're going to clean up this whole entire connection, and we're going to put the new one in, the new port. So let's fast forward to that point now where this port has been removed, and let's get to the other part where we get to put the new one in. All right, guys, we're back, and we have our old connector out, okay? And as you can see, this thing was really, really bad. I don't know if you can see, actually. I'm kind of just assuming you can see. But, you know, these pins were very mauled over, probably from me trying to take it out. So that's probably not, you know, something that happened beforehand. But the real reason why this port goes bad and makes loose connections is because of this sheath that's over this wire. It becomes very dulled, very mauled over. And inside of here, which this is obviously the old one, some of this plastic starts to wear away. And there's also metal hooks or tabs that kind of hold the cable in place. And over time and over use of being bent back and forth in different situations that you're in, they wear down and the cable no longer has a solid tight connection like it is supposed to have. So we just replace that, get it out of the way, and we put a new one in. Now this is kind of just pressure fitted right now. It hasn't been soldered into place, and that's what we're gonna do now. So by the way, we just kind of just pushed this in. I ended up, you know, picking this a vise and taking it off of the 90-degree position, went straight up and down so I could see both sides and where I needed to line up all these pins. And I lined up these 4 main connections first with the holes in the circuit board, pushed those through. Once I knew they were lined up, then I allowed these 2 ears to come through and secured them into place. And I kind of used my needle nose a little bit and the tip of, you know, this pick here, or even the flat-headed screwdriver to kind of just help them and guide them through once I knew for sure that those 4 pins were in place. Because if you don't do that, you're going to bend these pins while you're putting it in. So to avoid that, just remember, try to get these 4 lined up first and then go for the attempt of putting these 2 ears into place on the board. So now what do we have? We have 6 soldered connections that we need to create. 1, 2, 3, 4 here in the center, non-bridged, meaning no connection, separate, and then these 2 here, the ears. Okay, and that's what we're going to do now. So I think what we're going to try to do, let's hope this works out, is take some solder paste or flux, and we're going to kind of put some on the end of the pick. Okay, and what we're going to do is just kind of go for this top right one first and put a little bit of that. You know, I've seen people do this with a toothpick before, just to get these like precise soldered connections. This is like microscopic soldering in some cases, you know, and this is, if you're wondering how people do it, these are the tricks of the trade. Sometimes it's not the best tools you have, but it's things you've picked up for habits along the way that help. And like I said, I've definitely seen, you know, the old folks use like, you know, toothpicks. Just put a little bit of soldering paste on a toothpick and just coat that one connection. And what I'm doing, by the way, not to go off on a tangent, but, you know, it's kind of an important tangent, is make sure that soldering paste doesn't end up on the other pins. Because once we've made this first connection, we're going to clean this up and then go for our second, clean that up, go for our third, clean that up, go for our fourth, clean it up, right? And then these guys, since they're kind of separate from each other, we kind of know we can just drop 2 balls of solder on there and we'll be fine. But these 4 ones, it's very important that we don't create connections that we don't want to make. They're 4 separate pins. So what we're going to do is we're going to bring in our soldering iron and our solder. And hopefully I can do this to where you could see it. I know it's kind of tight quarters. But what I'm going to do is kind of just solder and keep feeding solder until a ball kind of, by the way, I'm heating up that at the same time. What I'm doing is I'm dropping, oh, there we go. That's beautiful. Okay. So I dropped it in place. The little ball, I kind of just touched the wire, and because that flux was on there, it's like a magnet. It just pops right on there and it sticks to it. And what I'm gonna do now is using my phone. I don't have my magnifying glass out here, but I can see that that connection is not touching the other. So I'm letting that cool a little bit. And as I told you previously in the video, this QD, you know, electronic cleaner from CRC is beautiful. It works wonders. We can kind of come in there. It quickly evaporates and give it a little spritz. Blow it away. Another little quick little spritz. Blow it away. I'm gonna give it one more inspection with my flashlight, my very fancy flashlight on my phone, and I see that we have a good connection. So we can now work for our second one now. Or work on our second one now. And we're gonna do the same thing. We're gonna take our pick, we're gonna dip it in some rosin. And the trick is to just touch the points we want that solder to flow to. It just works like a magnet, guys. So we get in there. Just let it touch that. Try to get some of it on the board around it. But I really want it to just kind of stick to that wire so that when it flows down, kind of just lands on the board around it. So kind of just being careful to stick to this side. And we're going to do the same thing. Repeat for 2 what we did for 1. like how that looks. There we go. Let's see what that did. Okay, just let that solder cool a little bit. Another QD spritz. And you can kind of see what it's doing as it's cooling. Right, you gotta get this like instantaneous like cool off period where it hardens up right away, but it's still kind of continuing to harden on the center. You can kind of see as you're doing that what it's gonna do. So let's turn our flashlight back on. And I want to see if I can stick a pick, very thin pick in between. Yeah, I can, which tells me they're not bridged. So I have this pick going in between the 2 points that I just made, very finely kind of sticking that pick in between there. And I can see that those two connections are not touching, which is beautiful. It's exactly what I want. So anyway, we're gonna do the same thing for the 2 other connections here. And when we've done that, we'll come back and solder up the last 2 points. Thanks for watching, guys. Okay guys, here we are at the point where we've soldered all 4 of those connections. We went in and did those other 2, and we're ready to kind of solder in those ears that hold us into the chassis. So if you can see, before I go ahead and do that, I want to show you that I've gone in and pre-inspected everything with this pick. There's a very thin pick, and I can run this pick between all of my connections on all sides with no interference. I know for a fact, and I've gone in with a flashlight, that none of these connections are bridged or touching each other. Another word for that would be shorting to each other. So we're going to go ahead and solder these 2 connections now. Okay, let's go ahead and do that. We'll grab our soldering iron and our solder. And I've given these a pre-moisten with some of that solder paste or flux, or starter flux paste. So we'll go ahead and just drop a couple of gloops, globbly gloops onto these connections. Just feed that in. Now you don't need a lot of it, you just kind of want to make the connection. Just gonna feed that guy in as we go in. Just keep feeding that solder in. It's not the cleanest connection in the world, or cleanest looking connection in the world. Sometimes what I like to do is just kind of go in and clean it up with the soldering iron as I go. I think the issue there was I didn't have enough out on the spool, so I couldn't really control it well, but now I should be able to go right in there. Feed that in. I'll use the phrase, good enough for my house. So let's go in for the other one. So I learned that one years ago, somebody I worked with years ago, when I was doing some home security, wiring in, glass break detectors and motion sensors and door contacts, window contacts. We'd go in the house, and this guy that was kind of new to the company, he would say, I would be like, are you sure that's good? He's like, good enough for my house. He would make me laugh. But yeah, as long as your connections are good, you're fine. This is protected, so this is nice clean solder. All right, that one actually went in a lot easier. Beautiful. So let me look at that from the other side. Yeah, no, that's good. So we're kind of done. That's cooled. I'm gonna give that a quick spritz off with QD cleaner. As you can see, it's very quick drying. I just kind of gave it a little extra assistance there, a little lung power. I'm gonna just kind of come in here and feel around these connections, make sure they're not loose. The solder points won't break off, you know, quickly. So it feels nice and solid, nice and solid. I'm gonna come in here, kind of check one more time. That's solid. Ooh, that's a loose connection. You know what? Let's go in there and drop another bead of solder. This is why it's always a good idea to go in and inspect your work and make sure everything's good to go, because you don't want to put this whole thing back together and you're like, why is it not working? Why am I still having an issue? So let's go do that now. Let's make that connection. All right, guys, so here we are. I did notice that this was kind of loose here, so I went in and kind of fixed that last connection. And again, I'm gonna, you know, reiterate on the point that it's always a good idea to go back and check all your connections, make sure everything's nice and tight, nothing is loose. The solder points are nice and strong, they're not weak. And you know, the worst thing that could happen is, you know, you go to put this back in the chassis and you got to take it all back apart because it's not working. So in fact, now that this is done, we know that this port is connected. You could actually take this circuit board without the chassis over to your computer, plug in this port with the USB 2.0 cable, type B, and confirm that the lights come on the front panel, that it's a solid connection before you put the chassis all back together. In fact, I highly recommend you do so. And that way you know for sure that it is working and all of the fruits of your labor have proven. So yeah, let's start putting this thing back together, and let's do that now. All right, guys, here we are back at the table. I've gone ahead and taken the liberty of plugging this into the computer through the USB 2.0 port. I confirm that I have solid constant power by pushing in the 48 phantom power, and it stayed solid red the entire time. No matter how much I wiggled on that wire to test it, we had a good solid connection, and thus I know I can go ahead and start putting this back together and placing this circuit back into the aluminum chassis. So let's go ahead and do that now. So as it came out through the front of the chassis, it's also to go in from the front of the chassis as well when we're putting it back together. Now it's important to remember, we have two tiers of circuit boards. We have an upper tier and we have a lower tier. As this came out, if you didn't notice before, on the inside of this chassis, we have two sleeves that perfectly mate with those circuit boards here and here. So when we're lining this up, it's important to kind of get it a push start and line up those two boards so that it lines up perfectly, and then we can just slide it in. Okay, so let's make sure we're mated up and lined up, and it should just slide in place. When you've felt it, just give it a little click. Those ears that we were talking about earlier will snap into place, and now it's in there solid. Let's flip this bad boy over. Okay, we're gonna reattach our back plate. Okay, the fascia will go back on with these 3 screws. Remember that the 2 shorter ones were for the corners, and the longer one was for the center. So I'm gonna go ahead and start screwing this back in, and get them pre-tightened. Tight enough. Tight enough. Don't over tighten it. Especially this one, because it's mating with plastic. You can definitely snap that, so be careful when you're putting that in. And I'm gonna go in, just give it one more double check, make sure everything's nice and tight. We're done with the Phillips head screws. Next task would be to replace these nuts onto our 1/4 inch jacks. You can hand tighten them for now. Go ahead and take our pair of pliers, whatever tool you want to use for this, and just tighten our 1/4 inch jacks down. Don't over crank these. You can definitely strip the threads because this is plastic. There's our right out, and this is our left out. And those are definitely tight enough. I can't loosen it by hand, which is great. And we're done. We can now take this over to the computer and give it one last test. Let's head over there right now. All right, guys, so here we are. We're back at the computer station. We have our interface that we've gone ahead and repaired. We've pre-checked it before we put it all back together, but we're gonna check it one more time before we go ahead and assume that this is perfectly normal. And the way we're gonna do that is just by taking our USB Type B 2.0 port cable, plugging it into the back of the interface. We're gonna plug it in, and let me see if I can do this so that you can see it. Okay, you've seen the lights flash. That's what it's supposed to do. Okay, came on. And one way to know if we have solid power, test it one more time, is we're gonna click that 48 volt phantom power, click it on. You can see that it's solid, and no matter what I do, if I wiggle this wire back and forth, we still have a good solid connection. It is not going anywhere. So we've confirmed that this works. Our repair is successful. Let's get back to recording some music. And in our specific case, you know, although we have many interfaces lying around the house, this happens to be my favorite because it is very mobile. 2 ports is all I need to do what I'm doing. And we're going to be scoring some film here soon, shortly. So thanks for watching. Again, this is Johnny Does It All. We do a little bit of everything on this channel. This is new, and just follow us around. I know these aren't the shortest videos, but sometimes in life, short isn't always the answer. Sometimes you need a full description and full you know, explanation of how something's done, and that's the whole purpose of this channel. So I hope I helped you guys in any way. Remember, I've dropped some affiliate links down in the description below. You won't pay any extra for that. Just remember, it doesn't cost you anything extra. If you need some of that solder flux, some of that solder, the connectors, any of that type of stuff, you can click on the links below, and it'll help our channel out. So thanks for watching. We'll see you next time. And this has been Johnny Does It All. Take care.